And hello, welcome back to Mr. Half Bacon. Today, we're going to be talking about calculus. We're going to be doing calculus, and basically calculus for beginners. And this is the first video, limits, part 1. Okay, so we all know infinity. I guess there's many different ways to represent it, but one way to represent it is it's like the amount of numbers between any two known real numbers. So like 1 to 2, 0.6 to 97, it doesn't really matter. So take 1 over infinity. Now, some could point out, hey, infinity is technically not really a number, but think of it, it's just a really, really big number. 1 over a really, really big number is near 0, and this ends up being 0. Now, we take 1 over x, right? That's a good function. Higher x goes, the lower it is, and it goes closer and closer to 0. So we're going to put x is going towards infinity, and 1 over x is end up going to 1 over infinity. So we can say that the limit, like what it's going to reach. So the limit, it's not going to get below 0, because 1 over something cannot be negative if it's constantly going up. So we can say the limit as x approaches infinity of 1 over x is equal to 0. Now, okay, so we're gonna talk about area now. But we're gonna technically use limits at the end. So we have a triangle, right? We know it'll be 10 centimeters by 10 centimeters. We already have a formula for the area of a triangle, but we're just using this as an example. So we take units of 5 centimeters wide. So we have we just fill it up as best as we can, and we have 3 squares, so that equates to 3 5 by 5 units. Now we're going to do this with 2 wide squares, 2 by 2, and you can fit 15 of them. Now, so I'm just going to general, so 3 5 by 5, 15 2 by 2. 55, 1 by 1, 210, 0.5 by 0.5, 820, 0.25 by 0.25. I would have had more graphics for farther on, but my computer can't handle it. But anyways, so calculating the area from those, basically approximation 75, 60, 55, 52.5, 51.25, etc. It's going closer to 50, which if you and this better shows it. But so essentially, if you have the area of the triangle is 50. So you can see it's getting closer and closer because let me go back. There's more of a gap and more of a discrepancy, but here it sort of slowly levels out. Here it's almost no gap. So I guess we can turn this into a limit equation, though it doesn't directly correlate since it isn't a function. But so we'll put the area as A, the width of the square is W. We're just going to say in general, limit as the width of squares equals W, and I should say approximated area. It essentially goes to 50. I can't really illustrate it that well because it isn't even really a function like f of x or something. But anyways, thank you very much for